Welcome to the DIY Honda Garage channel. In this presentation, we will discuss DTC C1242-12, which refers to a high voltage signal issue from the brake booster pressure sensor 1 in the Honda Civic model from 2022 and onward. The brake booster pressure sensor plays a critical role in the vehicle's braking system by monitoring the brake booster pressure levels. If the sensor detects any values exceeding the specified limit, it triggers the electric vacuum pump control unit to store the diagnostic trouble code, DTC, for further analysis. Components affected include the brake booster pressure sensor 1, its associated harnesses, the electric vacuum pump control unit, and the check valve connected to the intake manifold. Understanding this error is crucial as it directly impacts brake system performance and safety. DTC C1242-12 indicates high voltage detected from the brake booster pressure sensor 1. This sensor is responsible for measuring the brake booster pressure within the braking system, which is essential for optimal brake performance. It is typically located near the brake booster assembly in the engine compartment. And if the output voltage is higher than specified thresholds, it signals an issue to the electric vacuum pump control unit. This unit then logs the error code for diagnostics. The brake booster pressure sensor must function correctly to ensure that the brake booster operates efficiently, promoting effective braking in the vehicle. The causes of DTC C1242-12 can vary, with several primary suspects. First, there may be open wire connections affecting the system's integrity, such as broken or frayed wiring between the brake booster pressure sensor 1 and the electric vacuum pump control unit. Second, the brake booster pressure sensor itself may be defective or damaged, leading to erroneous high voltage readings. Lastly, a malfunctioning check valve could also contribute to the pressure discrepancies within the brake booster system, resulting in misreported pressure levels. Each of these components plays a vital role in ensuring accurate sensor readings and overall brake performance. Symptoms associated with DTC C1242-12 can manifest as various braking issues. Drivers may notice performance problems, such as decreased responsiveness during braking or a spongy brake pedal feel, which indicates that the brake booster may not function optimally. Additionally, the vehicle's onboard diagnostic system may activate a warning light on the dashboard, alerting the driver to the detected fault. If these symptoms surface, they signal potential risks in braking efficacy, prompting immediate attention to prevent further complications. Understanding these symptoms can assist in quickly identifying the underlying issue linked to this DTC. The first troubleshooting step for DTC C1242-12 involves manipulating the vehicle's ignition settings. Begin by turning the ignition to the on mode, which activates the vehicle's electrical systems without starting the engine. Allow the system to stabilize for at least 2 seconds to ensure all diagnostics and voltage readings are accurate. Following this, switch the ignition to the off position. This step is crucial as it resets the vehicle's systems, allowing the subsequent steps to gather accurate data about the sensor's performance and any potential circuit issues. The second troubleshooting step requires inspecting the external circuits related to brake booster pressure sensor 1. Begin by verifying the integrity of the sensor 1 signal line, ensuring that there's continuity and that no open circuits are present. Next, check the sensor 1 ground line to confirm it also shows less than 1 ohm resistance. This step helps identify any interruptions in the wiring harness that may lead to erroneous high voltage readings detected by the sensor. If abnormalities are observed in this inspection, addressing them becomes critical before proceeding to test the brake booster pressure sensor itself. In the third step, focus on inspecting brake booster pressure sensor 1 for malfunctions. Begin by performing functionality tests to assess if the sensor operates within specified parameters. It's essential to also check for any physical damage or signs of wear that could affect sensor performance. If DTC C1242-12 reappears after confirming that the sensor is functioning correctly, further investigation into the wiring and connections is warranted. This step is crucial because a defective sensor directly affects the measurement of brake booster pressure, leading to inaccurate readings and potential safety issues. The fourth troubleshooting step involves starting the engine to simulate normal driving conditions. Next, a test drive is required to observe the vehicle under real-world conditions, allowing the brake system to engage fully. During this drive, accelerate until the turbocharger engages to assess the braking system more rigorously. Importantly, keep in mind that the test should be performed on the road, not on a lift, as this will provide a clearer picture of system performance. After driving, check for the reappearance of DTC C1242-12. If no error code is detected, it suggests that the issues may have been resolved. However, if it persists, further investigation into the intake manifold side check valve may be necessary. Finally, it is crucial to conduct final repair verification after steps have been completed. This involves verifying that all repairs performed are correct and that the underlying issues that caused DTC C1242-12 have been rectified. Following this, perform a full system scan to evaluate all the vehicle's electronic systems. It's vital to confirm that no additional diagnostic trouble codes are present, as lingering codes can indicate unresolved issues. Completing this verification process ensures that the vehicle is safe and fully functional, hence restoring optimal brake performance. Attention to detail in this verification phase is key to ensuring the longevity and reliability of the repair. Preventive maintenance is essential to avoid future occurrences of DTC C1242-12. Regularly inspecting all brake components, such as the brake booster pressure sensor and associated wiring, can help catch potential issues before they become significant problems. Additionally, consistently monitoring sensor outputs for unusual readings can serve as an early warning system, alerting technicians to possible faults. Ensuring that wiring connections remain intact and free from corrosion will help maintain signal integrity to the sensor, thus preventing erroneous high voltage readings. Implementing these practices will contribute to the overall reliability and safety of the brake system. In conclusion, DTC C1242-12 reveals a critical issue related to high voltage output from the brake booster pressure sensor 1 in Honda Civic 2022 and newer models. Understanding this diagnostic trouble code is essential for identifying the causes and symptoms that may affect braking performance directly. Following a structured troubleshooting approach ensures that any underlying problems are efficiently addressed, thus restoring the proper functioning of the braking system. It's also crucial to implement preventive maintenance measures to avoid future issues. By staying proactive, we can ensure optimal vehicle performance and safety. Please like and subscribe to the channel. See you next time.